P2GreeN webinar, A Wave of Change for Better Water Solution. I'm Silvia Anastasia from Over, and I will guide you during this webinar together with my colleagues from Over. I'm delighted to have you join for this pivotal event organized by this P2GreeN project. This is a side event of the EU Green Week 2024 that was organized in Brussels and online yesterday and the day before. And the central topic for this year was the need to make EU more water resilient today and tomorrow. Our focus of today's webinar, which is the third part of our international conference, is on tackling global water issues by embracing sustainable innovative solutions that are essential for our future, with an emphasis on bioeconomy as a driver for the future and circular economy as a pathway for transformating change. This is the last part, as I told you, for this international conference that was a journey from farm to fork and from fork to farm. Indeed, we took part in March at the Bioeconomy Changemaker Festival set with a satellite event, and the title of this event was Bridging the Gap Between Thriving Bioeconomy and Youth Engagement. The project organized as well last week a World Café on sustainable and circular bioeconomy in Gotland during our consortium meeting, and you will learn more about it later on. Finally, this side event today brings together experts and stakeholders to discuss the critical integration of water management, agriculture, and circular economy. At P2GreeN, we are at the forefront of transitioning from traditional system to circular models, with a particular focus on transforming waste into valuable agricultural resources. We strongly believe that the shift is crucial for addressing water pollution and advancing in sustainable practices. Our event features a series of insightful presentations, and I'm very glad for this, and discussion, and I will present a bit more the people that is joining us today. First of all, Anita Becklet from Agrater will give a strategic overview of the subject, presenting P2GreeN cutting-edge methods to combat water pollution and advance circular solutions. Afterwards, we are going to enjoy the presentation from a Spanish pilot, which delves into the discussion on improving water governance in intensely irrigated areas like Xia, Spain, with contributions from José Manuel Nieto from Setacqua and Gerardo González from BioSul. In addition, Carsten Benneker from Agrater will explain new sources and separation techniques, exploring detailed insights on how these techniques can relieve water resources stress and mitigate emissions into water bodies. Finally, Laura Vivani from Movere will present some insights into sustainable bioeconomy, highlighting the outcomes of the World Café organized by the P2GreeN International Conference related to sustainable and circular economy. Each session includes a dedicated time for question and answer from your side, ensuring that participants can engage directly with the expert and gain a deep understanding of the topic discussed. Therefore, participants are encouraged to interact with. We are going to use Slido, and there are going to appear information on the screen, or just if you want, raise your hand, and I will give you the way that you can participate to the event. Now, I'm happy to leave the floor to Anita, and she will go on with the presentation. Thank you to all for coming.
Thank you, Silvia. Will you start the presentation? Yeah. Okay. Hello to everyone, and I'm very glad that you are joining our webinar today. And I would like to give you a brief overview about what P2GreeN is contributing towards the EU water agenda. And if you could move to the next slide, please, Silvia. The EU is fostering a water resilient Europe. And our topic in P2GreeN is specifically focusing on piloting innovative governance solutions to limit nitrogen and phosphorus emissions at the interface of rural, coastal, urban, and industrial environments. Our vision is that we basically close the circle between the urban areas where a lot of wastewater is produced and mostly not used and not reused. And by closing this loop, also using very precious resources in terms of nitrogen and phosphorus and turning them into bio-based fertilizers, thereby closing the loop on the rural side for farmers to apply them on their fields as a replacement for conventional mineral fertilizers. And by that, the ultimate goal for P2GreeN is to transform the waste management system and close the cycle using the 3R principles: reduce, reuse, recover. Next slide, please, Sylvia. I want to give you a brief overview before we go into more details, also with our pilot region, especially in Spain today. You may know this picture. This is basically showing the system's boundary and basically the access so far today we have with our ecological boundaries in Europe. And P2GreeN therefore is concentrating on halting nitrogen and phosphorus pollution and limiting these pollutions also. And you can see from the graph, these are very relevant polluting indicators so far. Next, please. I would like to give you some details so that you can follow why P2GreeN is also concentrating on water issues. What you can see on the left-hand side of this slide is basically the current status of our surface waters in Germany. This is a status report from the German Environmental Protection Agency. And the first picture is on the chemical status of the surface waters. One should know that across Europe we have the Water Framework Directive, and this Water Framework Directive is applicable at all member states level, and it requires monitoring and also measurements from the national member states. And for the chemical status of our water bodies, it is required that we maintain a certain level or that we eliminate pollution. For that, a set of indicators is created and monitored at each member state's level, and these indicators are plentiful. In total, they are 50. And what you can see here, and obviously the aim is to have the condition of overall a good chemical status, which means that the pollution level is basically within safe environmental boundaries. What you can see here on the chemical status of surface waters in Germany, for example, is that all, and I mean really all, water bodies in Germany have the status of not good. And that is basically an indicator of how bad we have already polluted our water bodies in Germany. On the picture in the middle, you can see the ecological status of our rivers and streams. And that is another indicator and another measure of monitoring what the water quality is all about. And again, this is applicable to all EU member states. And from what you can see here is that basically, although it is not shown in numbers, but if you calculate it, only 8% of the river and streams in Germany are in a good or very good status, ecological status. So 92% are not in a good ecological status. And the main contribution here for that state of play is basically coming from agriculture. And this is also one of our biggest reference points within P2GreeN. And that has a lot to do with excessive application of mineral fertilizers and also manure from animals. And then, this is probably also explaining why the Spanish pilot region is in the focus of our webinar today. What you can see here is a map from 2023 showing the drought status in Spain. And from what you can see here is that the ones who are in orange and in red are either on drought alert or emergency level. Breaking this down in meaningful numbers, this means in 2023, 9 million inhabitants of Spain were affected by drought. This represents 1/5 of the overall population in Spain. And coming to the province of Malaga, where our Spanish pilot is also located, for 2023, over 400,000 people alone in the province of Malaga were affected already by water restrictions. That is 1/4 of the population in the province of Malaga. So that gives you an overview about the state of play and the critical situation, not only in so-called Mediterranean countries, but also in countries like Germany and all across Europe, where our status regarding the water quality, the ecological and environmental impact that we create on our water, and also on the other hand side, how drought and also climate change is affecting water supply in all across Europe. Next slide, please. So, summarizing it in a nutshell, why we at P2GreeN want to work on these topics and why it is important also to work on them. We have these high NNP loads, and they are basically, as I showed you before, threatening our terrestrial and also our aquatic ecosystems. The agri-food sector is a major contributor to that, but also is heavily dependent on water, and sufficient water, and water in a good quality. And here, our municipal waste streams can really play a major and a crucial role in transforming this problem and challenge, and thereby also reducing our dependency on mineral fertilizers, closing the nutrient cycles by regaining nutrients from the waste streams that we produce. And then by that, with our technologies, which Carsten and other colleagues will explain later, we can really turn our waste streams, our water waste streams, into something really meaningful, and something that for the agricultural sector could be a good replacement for conventional fertilizer, and by that also contributing to less pollution in our water bodies. So next slide, please. And now I would like to hand over because I think that was a good overview, but obviously it is very important and very interesting for those of you who are joining us from outside to get a better understanding what we are currently doing in our pilot regions. We have 3 of them, and today we are focusing especially on the Spanish pilot region. And to give you an outlook, this will then also be upscaled to other follower regions. They are specifically in Greece, Italy, France, and Hungary. And then I hand it over to our Spanish colleagues. Thank you so much.
Thank you, Anita, for your presentation. It was very highlight. And before going on, I would like to ask all of you your comments on this, and there is some way to interact with you. Alexandra, can you please show your screen? Please have a look at this, and if you can use Slido, go on slido.com, insert the number, and try to answer this question. What are the most significant barriers to improving water management and governance, in your opinion? And let's see if we can have a look more in deep into a potential answer to this question today. Probably our colleagues from Spain and from Germany can give it to you an overview and just give it to you a potential answer to this. So please let us know what are the most significant barriers for improving water management for you. Let's see what is coming out from this question, and let's see how the ideas and solutions were just implemented in Spain, for example, in Andalusia. And also which kind of ideas were starting implementing in Germany. Yes, first of all, political commitment, normative framework, technology lock-in. Yes, okay, certainly there is a big part of our project talking about which is the political commitment and governance commitment, especially related to this technology. Apparently, it's a very key point, and you will see later on. The general framework, the lack of awareness also of in citizen and the citizen engagement, it's very important. And obviously the water-related policies are coming in very critical mass. Yes, also finance. We were discussing, you will see later on during our meeting in Gotland, how important it is to have investments on this side. But it's really, as you were mentioning in this, the political commitment and the general framework, the justice framework, it's very important to have the very critical shift from a system to a new system, more circular one. Thank you very much for engaging with us today. And now I will go back to the presentation, and I will leave the floor to José Manuel Nieto. Thank you very much.
There we go. Thank you, Silvia. Can you hear me well? Okay. Well, here me and Gerardo, we are going to present for you our pilot site in Spain from the P2GreeN project, in where we are using reclaimed water to manage smartly some irrigated crops with mangoes and avocados. So can you please go to the next slide? Okay, so water reclamation has become an outstanding alternative to provide water for different uses across all productive sectors. However, there are remarkable differences when we look throughout Europe, which allow us to see the main sectors using water in each country. So, for example, if you look at the map, in the south, we can see that agriculture is quite more important, providing the rest of Europe with a big amount of fruits and vegetables. On the other hand, Central and Northern Europe have a more powerful industrial sector, which concentrates the most of water use in those areas. However, only 2.4% of water is reused in Europe coming from urban wastewater, which is an absolutely low number, and for which we all need to make great efforts, mainly in terms of policy making, as we have seen in the slide. So if we make a focus in the Mediterranean area, some studies have predicted remarkable reductions of rainfall in this area, as well as temperature rising because of climate change, which put the focus on the searching of alternatives for satisfying a higher water consumption linked to the increasing population and, of course, an increase of the tourism. So it is necessary to look for different ways to satisfy the water needs for different uses, such as water reuse and reclamation, which is our main topic here. So can you please go to the next slide? Okay, so if we make a zoom into Spain, so here you can see the percentage of reused treated wastewater in the different regions of Spain. The average percentage of the country is 10.5, 10.4%. And if we take a look at the Andalusia region, where Malaga and our pilot site is located, this percentage goes down to 5.9%. But some other regions, has Murcia or Comunidad Valenciana at the eastern part of Spain, reuse more than 40% of their treated wastewater. On the other hand, there are a few regions that do not reuse treated wastewater, as Extremadura or Navarra, among others. This clear difference is due to a higher investment and involvement of the regional governments, which saw a clear opportunity in water reuse. This also coincides with regions where water is quite scarce and agriculture is very developed. So a good water supplying infrastructure is needed. Can you please go to the next slide? Okay, so in this map, we can see the 5 kinds of uses are shown or reflected in the Spanish law about water reuse, which are agriculture, industry, garden and leisure areas, streets, and sewage and streets and sewage cleaning, among other uses. These other uses include the environmental ones as aquifer recharge, non-accessible green areas, irrigation and forestry, and other environmental uses as the maintenance of wetlands or river outflows. In Spain, the uses vary significantly between regions, like it was happening in Europe. So in the north, treated wastewater is mainly dedicated to industry and other uses, while in the east, agriculture is the main one. In the south, but also in Madrid, like we can see in the central part, and Galicia, in the northwestern part of Spain, the use for gardens and leisure areas is the most common. In the islands, in the Baleares and Canary Island, this last use is shared with agriculture and urban uses because the availability of water there is very low. So we can see here, if we take a look at Andalusia, there's a poor reuse for agriculture here. And agriculture, as we are going to see later in Andalusia, is quite important. So the public administration must adapt to the new water culture, as well as to the increasing water scarcity, as Anita mentioned. And of course, they have to make a big effort in promoting the reuse of treated wastewater. These efforts must be even higher in the Andalusia region, where, among others, groundwater is a commonly used resource and the reclaiming percentages are very low. Furthermore, the environmental uses do not exist practically. So, apart from policies, there is a lack of well-trained technical supervisors in the government who should have an interdisciplinary point of view for assessing the required parameters in the water design for a specific use. So if we can go to the next slide, please. Here, we have made another zoom into the Andalusia region in southern Spain. You can also see inside that red frame where our pilot site is located. So you can see here with black points the location of wastewater treatment plants with tertiary processes. So the output of the waters should be quite nice, or should have nice parameters for irrigating some kind of crops. And in blue, you can see all the potentially irrigated lands in Andalusia. Of course, not all of them, of those lands and areas, are currently irrigated, but they can be irrigated. So we can see a huge potential for using reclaimed water to provide alternative water sources to these crops. And of course, we have to take care, take this in consideration, because here there is a growing high water consuming crops, like in the inner part of Andalusia. There are new intensely irrigated olive orchards, and of course, new subtropical fruits like maracuja that are starting to rise in southern Andalusia. And of course, if we look at the western part of Andalusia, there is a very high number of hectares of irrigated berries, which consumes a high amount of water. So that's all for my part. Now I give the floor to Gerardo.
Thank you, José Manuel. Good morning, everyone. I will continue with the description of our pilot region. I would like to take you and zoom in a little bit into the Axarquia region where our pilot is located in southern Spain, in the province of Malaga. This is a region with around 31 municipalities involved, and there is a strong agricultural sector, which for you to have an idea, it used to have a turnover of around 150 million euros in the province of Malaga, especially in the subtropical fruit sector, with the vast majority of these crops produced in the region of La Axarquia. So for this, La Axarquia has become the main producer of subtropical crops in Europe, mainly for avocado and mango trees. And however, these very promising figures are now outdated since the water crisis that we are suffering over the last years has decreased the production of subtropical crops and has reduced to half the turnover in the province. And this is due mainly to the water scarcity episode that we are suffering for the last years. For instance, the water reservoir La Viñuela, which is providing water to the irrigators in the area, until very recently, it was at less than 10% of the capacity. On top of that, we also have problems with diffuse pollution due to the contamination of surface and groundwater, and we are located in a vulnerable zone as well. And considering all these factors, the interest in the use of non-conventional water sources has increased over the last years. And if we can go to the next slide, please. Yeah, so here what I would like to present is the value chain in our pilot project, with the main objective of demonstrating the use of nutrient-optimized fertigation using reclaimed water. In that sense, in our pilot, we are collaborating with Axaragua, which is the public water operator collecting and treating the wastewater from the municipality of Algarrobo. At the wastewater treatment plant, wastewater is treated and it is discharged afterwards to the sea. But in our pilot, we are incorporating a water reclamation plant, which is operated by Azul, to pump treated wastewater after the secondary treatment and produce reclaimed water that will be eventually used to irrigate avocado and mango crops, which are managed by TROPS, which is a cooperative of farmers. As you know, the reclaimed water is an alternative source of water for irrigation that also contains nutrients for the plants. And this is a great opportunity, right? But it is also a challenge if it's not monitored and applied to the crops appropriately. So in this sense, in order to optimize the control and the application of nutrients and water to the crops, we are developing a smart fertigation tool with a decision support system incorporated with a technology provided by AgriSmart Data, which is another technology provider, part of our pilot. Next slide, please. Yeah, I would like also to show you here an aerial photo of the pilot, where we are trying to replicate a real scenario with the farmers using reclaimed water for irrigation in agriculture. So you can see that we have the municipal wastewater treatment plant, and the water reclamation facility is located at the premises of the treatment plant. From there, we are treating the effluent, and we pump the reclaimed water to a nearby plot where we have the field trials. We have a mixing unit where we are storing reclaimed water, but also local water. And in the field trials, we are irrigating avocado and mango crops. So this is for you to have an idea how it looks, and this is more or less replicating a real scenario. Next slide, please. Yeah, for the water reclamation facility, we are using a filtration technology consisting in disc filtration to remove the suspended solids and the organic matter in the effluent that we receive from the wastewater treatment plant. We can also remove some microorganisms such as nematodes, and the filtration prepares the effluent for the next step, which is the disinfection with ozone. And we also include a sodium hypochlorite disinfection step for maintenance and to avoid the growth of algae when we store the reclaimed water in the deposit tanks. Let's go to the next slide, please. Yes, in terms of the applicable legislation, since 2007, we had in Spain a national royal decree that was the legal framework for the reuse of treated wastewater. But now we are in the process of transposing the legislation to comply with the EU regulation that was in force since the last year. And it sets the minimum requirements for the water reuse with different water quality categories, depending on the final use of the reclaimed water. And it also indicates the parameters and the frequency for monitoring. So we have to comply with the E. coli levels, BOD, total suspended solids, turbidity, and so on. So we have a very complex and complete monitoring campaign to take samples and ensure that we are complying with the European regulation. Next slide, please. Yeah, and I think at this point it's also important to stress the high agronomic value of the reclaimed water as a biofertilizer. In that sense, we are analyzing the content of nutrients present in the reclaimed water in comparison with local water. And you can see in the table that the presence of some of these macro and micronutrients in the reclaimed water is very significant. And these are average values of the samples that we have been taking every month for the last year. And we pay special attention to the macronutrients like nitrogen, phosphorus, and potassium. Next slide, please. Also, we have started to estimate the percentage of nutrients needed by the crops, which are covered with the use of reclaimed water. So this is just an estimation for the avocado crops according to the fertilization plan and the quantity of the mineral fertilizers that farmers usually apply to their crops. And the percentage is quite high for nitrogen, phosphorus, and potassium, as you can see, but also for other nutrients such as calcium or sulfates. Next slide. This is the estimation for mango crops. The figures also look even better. And for instance, the demand of calcium and iron is covered completely with the use of reclaimed water. So we keep analyzing the quality and also the demand of the crops with the different campaigns that crops is applying to the crops. And next slide. So, as I said earlier, the content of the nutrients in the reclaimed water is a big opportunity, as we can see, but it's also a risk, or it could be a risk if it's not controlled and managed properly. And that is why we, in our pilot, are developing a smart fertigation tool and a decision support system to control and optimize the amount of nutrients and irrigation using reclaimed water to save water and mineral fertilizers on the one hand, but also to avoid the over-fertilization and be able to prevent potential leaching of nutrients to the groundwater. So we are applying or installing different components such as dosimeters and tensiometers, electrical sensors to measure the nitrogen, phosphorus, potassium, humidity, electrical conductivity, and other parameters as well, connected with IoT controllers. And you can move to the next slide, please. So the goal during the P2GreeN project is to advance in this technology from a technology that is demonstrated in a relevant environment to a final system that is complete and qualified. That would be TRL level 8. So the first step now is to have a digital tool that provides information on the levels of the main nutrients and the elements in the soil that most affect the development of the crops. And in a second step later on, to have the remote control over the dosage of the fertilizers and the mixture of water sources automatically by using a decision support system. And next slide, please. Yeah, and just to conclude, I wanted to add the main applications for the use of reclaimed water and smart irrigation combined, which are divided into agricultural use, urban use, environmental use, and recreational use. So these are applications registered or considered in the water reuse regulation, or at least in the Spanish Royal Decree. Yeah, this is just for you to have an idea of the potential uses that we could give to the solution we are providing and developing in the Spanish pilot. And I think that was my last slide. Thank you very much.
Thank you very much for the presentation. It was very inspiring. Now is the moment for all the public to ask questions. At this time, we are going to share with you the link in Slido. So please insert the code in slido.com and you can write the question there. In the meantime, waiting for the first question, I have actually a question. The cost of installation of the water reclamation facility, I don't know if you have already, we also have a question from public, but I will finish with mine first. I don't know if you have already a reflection, if there is any data already of the potential cost of this installation of the water reclamation facility, and if it's economical benefit for farmers to use it. So if in the end it will be beneficial for them.
Shall I start?
Yes, please.
I think we will be able to give you more accurate data later on in the project, because currently we are collaborating with some partners in P2GreeN to develop the circular model, the circular business models to identify the value creation, the flow of incomes. So we are working on that at the moment. We will be also working on a cost-benefit analysis of each of the solutions. And so all this information will be made available for everyone during the project. So yeah, I will keep it here for the moment.
Okay, thank you very much for the answer. I will go on with the question from the public. So, what lessons from the Aksakira project can you apply to other regions facing water scarcity, sustainable water management challenge? So, is it very local, or can you apply the model somewhere else?
Well, I can answer that question.
Please.
Well, here we are learning some important lessons. As we have to take care about the output quality of reclaimed water, because sometimes you can have some issues with another parameters that are let's say outside of our main topic of nutrients, which is optimal. But for example, you can have some problem in Mediterranean coastal areas regarding electrical conductivity. So that's a lesson to learn, to establish previous management systems to regulate the salinity of that water, so you can irrigate correctly some crops. That's one lesson. And another one, of course, is that this is a very feasible system that can be applied in a lot of different crops all among Europe, not only in the world, not only Europe, and of course not only in subtropical crops like here. You can also apply this to olive trees, to berries. So of course, you have to look for a risk management of all this.
Thank you very much for your answer. We have another question here. So, how have you worked to increase awareness and capacity development among municipalities, farmers, and other stakeholders? We know from before that it was a big issue. So, how did you manage to increase awareness?
I can take that one, maybe, or I can start.
Thank you.
I think in P2GreeN, we are having the opportunity to organize a lot of workshops and participatory processes also, where we are inviting to participate other stakeholders, not just in our region, but from other regions, from other projects as well. And we have the opportunity to discuss, to exchange knowledge, to learn about the best practice. And I think by involving all the actors together, we can increase awareness, and we can also try to develop and create capacities that we detect that are needed. So in terms of training in the use of the technologies or the interpretation of the legislation, there is also a big issue with the bureaucratic and the administrative process that they have to follow to request water reuse licenses. So by having this interactive and participatory events, we can really increase awareness of what we are doing, and also prepare and cope with the needs that they might have in terms of capacity development.
Thank you very much for the answer. I don't know if there is any other questions. Just let's wait a second if there is any more questions from the public using Slido. I think that your pilot and what you showed, it was very inspiring. Okay, apparently there are some other questions. What are the economic potential benefits for an SMA using the P2GreeN solutions? I don't know if at this stage it's already clear this, or if there is any potential economic benefit for SMAs that it's already foreseen. Thank you.
Well, I will say that, of course, a saving in artificial fertilizer, that's the first economic benefit. But of course, a saving of water costs related to this. So to me, those are the main benefits regarding the economic point of view.
Okay, thank you very much. And Anita wants to add something related to this, maybe?
Yes, I think there are two aspects I would like to mention. First of all, it really depends on the type of technology we are looking at, because we have 4 different type of technologies we are exploring at P2GreeN. And for that, it depends on the environment the technology operators are operating in. And as with our system, it is a system that is focused on a circular business model. The answer is not that clear and that easy, and that is also part of what P2GreeN will work on during the next years, to come up with specific data on costs per technology, because the difference compared to, I would say, conventional technology used so far is that within a circular economy environment, the cost calculation is much more complicated because it needs to take into account the system as such. Because if we are closing the whole value chain cycle, then these costs need to be incorporated and be then offset compared to the benefits you gain. And that is also one of the major challenges. And for that, I refer to Jose Manuel, who also said, and also Gerardo, about challenges in the governance framework, because this kind of true costing or true cost accounting is not applied towards the conventional applications. And that then gives us a slight disadvantage, because you're not comparing like with like. Thank you.
Thank you very much for your vision and your explanation, Anita. Thank you very much. And I see that there is one last question, so I will go on with this one. So this topic looks very interesting for all. What role do you believe the bioeconomy plays in the future of sustainable water management? I don't know, Geraldo, Manuel, who wants to?
I can kick off. Well, I think it's I think the role of bioeconomy is very relevant, for instance, in the promotion of the use of bio-based fertilizers. And also, which is applicable to our pilot, is the advance in the precision agriculture. So we can also optimize the use of water for irrigation and also prevent the potential leaching of fertilizers into the groundwater. And also, I think the bioeconomy action plan is clearly promoting the creation of circular systems, like circular business models where waste is reduced, resources are reused. So in the context of water management, this means developing systems where the wastewater is treated and is reclaimed for different uses, like irrigation in agriculture, and also decreasing the demand of conventional fresh water. So I think it plays a very important role.
Thank you very much for your vision. And now I will give the floor to Karsten for the second part of this presentation. So I share again my screen.
Hello, everyone. Can you hear me well?
Yes.
Yes, fine. Thank you for the opportunity. It's a pleasure to be presenting here the approach of source separation to relieve stress from water resources and mitigate emissions to water bodies. In our use case in Germany, but the approach can be transferred beyond Germany. My role in P2GreeN is to coordinate this pilot region with our partners. One of the partners is Buna Nexus from Switzerland, and I will take the part of David Deschambrier, who was supposed to present their technology of urine treatment. Yeah, I will do that for today. And let me first start with an introduction what source separation is. On the next slide, please. So it provides system components that can be applied in various ways, from decentral to central, and that can be also combined with the benefits of the conventional sewer system, while taking advantage of the resources that are actually kept within the wastewater, such as nutrients and the water itself, and can get rid of contaminants that are included. I brought here one example, a Sankey chart of an example where the Vuna treatment system was also planned for. Basically, the idea of separating water streams is the same like with the solid waste that you know from your trash bins maybe at home. If we separate the plastics from the carton and from the metal, it is just much easier to later on reclaim them and give them value and a new life. And the same is true for wastewater. If we look at the different streams, we see there's different qualities. Fecal matter, like the solid fecal matter, has a different quality than the urine, and the water we are using for hygiene also has a different quality. So these can be diverted within the domestic use, and depending on their quality, be given into a separate treatment. In this example, you can see it is a hybrid system. It is taking, it is actually making use of the municipal treatment, where the most, the waters with the highest load of solids and pathogens go to. And then the yellow water stream is treated on site, as well as the gray water stream, while the gray water is reused as process water for the toilet flush. The yellow water is treated on site to produce urine, a fertilizer. Can we please go ahead with the next slide? This is an example how it can look like in a building integrated approach. It can be up to 5 different pipes on the waste side, and then you have 2 distribution pipes on the supply side with different qualities, ending up with new kind of drawings like you see here, with more pipings that separate the waste water. Please go to the next slide. What is the motivation behind it? Well, if we look at the volumes of the domestic water use, we have to constitute that 1/3 is used in the water toilet for flushing comparably small volumes of urine and of feces. So it's only about 1% of the wastewater volume that actually contained of urine. These are the amounts here per person and year. 700 barrels of wastewater, out of which 9 are actually urine. Next slide, please. So if we take into consideration that we have only 1% of wastewater volume and look into the chemistry, you see it comprises 70 to 80% of the nitrogen and 45 to 60% of the phosphorus that is contained in wastewater, while also carrying most of the pharmaceutical residues. Those pills that some of us have to take, they are not fully digested and usually excreted mainly with the urine. So the approach of source separation has the potential to redirect these nutrients where they are most needed, which is the crop production, whilst taking off the pharmaceutical residues, which could be harmful for the environment, in a very targeted way, treating much smaller volumes than if we would treat the entire volume of wastewater. On the next slide, I would also like to stress out that it's not only the potential of producing fertilizers that we have in mind, but also to direct less nitrogen to our oceans. In our deliverable 1.6, we aggregated some numbers that you find here on the table. And you can see that the largest share of nitrogen is actually released to water bodies coming from agriculture, but there is a significant share that is also coming from wastewater. Looking into the countries, you find very different relative numbers. From Sweden, where 1/3 of the nitrogen released to water bodies is actually coming from the wastewater system. In Spain, it's only 6%. But if you look at the absolute numbers in the last column, you can see it's really still large amounts of nitrogen, activated nitrogen, that are released. Germany is top 10 and Spain is top 20 nitrogen emitter of the world. And what is the result? The result is death zones in the oceans, algae resulting from algae blooms, like you see on the picture here with the algae around Scotland. But it also results in a climate effect, since this active nitrogen is processed to become nitrous oxide in the ocean, which is a very harmful greenhouse gas, 300 times more potential than CO2. Next slide, please. So we have 4 different approaches in our project P2GreeN, and 3 of them are source separation approaches. Gerardo and Jose Manuel, they showed you the blue path, basically, tapping into the conventional system. In Sweden and Germany, we're working with source separation. In Sweden with urine, and in Germany both with feces and urine. Yeah, I would like to show you first how this source separation can be done, what user interfaces you would need on the next slide. So you need a redesigned toilet, and the most modern ones are using this urine trap or P-pot principle to divert the urine into a separate pipe. There's models for flush toilets, like you see on the left side, with a reduced water demand, and you see dry toilet designs like on the right side. So this new design helps not, so the new pipe, the additional pipe is not blocked, and the toilet is not perceived something weird or something unconventional, and thereby is more broadly accepted by the user. In the middle, you see a picture like for the flush toilet, you obviously need a second pipe, and this is how it can look like. Next slide, please. So the approach is then taking that urine, or we call the flushed urine yellow water, to become a fertilizer. But for doing that, it needs to be processed. We also want to take off the contaminants, as I said before. So we will have to look into the treatment technology, and that's where Vuna Nexus comes into play. On the next slide, please. The urine treatment process by Vuna Nexus is a 3-step process, basically. After the collection and storage, there's a activated sludge process to stabilize the ammonia from the urine by nitrification. And that already takes off the bad smell and transfers ammonia to nitrogen. And then in the next step, the liquid is filtered in a granular activated carbon filter. And this is where the pharmaceuticals really effectively are filtered off, as well as the hormones. Then in the third step, the liquid is concentrated and hygienized with heat, so the pathogens die off there. And what is left at the end of the process is a liquid that contains the nutrients that were excreted with our urine in a concentrated way, without the pharmaceuticals, without any smell, and it is actually already certified in Austria and Liechtenstein and Switzerland under the label urine. You can go to the next slide. Yeah, I brought two pictures. On the left side, you see the container-based treatment plant by Nexus, and on the right side, the building integrated one. Only so that you have an idea of this, how the system looks like. It has a rather small footprint and not so much technology that is needed besides pumps and a blower. But the intelligence is actually in the control system. On the left side, that one is integrated in a 20-foot container, and then there's an additional 10-foot container for the distiller that you cannot see in this picture. Let's go to the next slide, please. So, as I said, the end product is already on the market and not yet in Germany, but we have permits in the work, both in Germany and in France, by mutual recognition. And there has been a lot of data gathered also on the quality of the fertilizer. And yeah, Wuna actually receives a lot of positive feedback, and there's a certain demand by business customers such as cities to make use of this resource. Next slide, please. Yeah, I want to show you also how what we do with the feces. So feces are collected in these dry toilets by our partner Goldeimer, mainly on events. Like on the left side, you see a toilet from the allotment garden. In the middle, that is like a battery of toilets from events. And on the right side, you see the conventional, almost conventional waste bins that are used. The part that is not conventional is that they can be sealed and locked to avoid any inconvenient smell from them, and also avoid the release of pathogens into within the logistics to increase the security for those who have the labor with it. Next slide, please. Yeah, then those bins are transported to the resource hub, which is located in our case at Parkhof in Harburg, where a 3-staged composting process is following. The first one is in a sanitization container, a commercial product, an aerated container, where for minimum 1 week, temperature of 70 degrees is created just by microbial activation. And in the second stage, the composting is following in an earth flow container, also a commercial product, where really the goal is to create a high value compost. And then the third and last step is the screening to get rid of larger particles or components that are not wished to be ending up on the field later on. Next slide, please. Yeah, there's more pictures on the top. That's the first stage, the sanitization. And on the low one, you see the earth flow container with this motor-driven whirl that is moving through the compost continuously. So it's a highly automated process. Next slide, please. Yeah, another picture of that one. But I think we can go on. So in the end, from these source-separated wastewater streams, we generate two different products, two different recycling fertilizers, the liquid one from urine and the solid one from the solids, obviously. And I would like to stress out that they have different characteristics. Like the urine-based fertilizer can really compete with a mineral fertilizer, whereas the right one is a high-value compost, so it doesn't only reclaim nutrients, but it also is a soil conditioner, which can improve soil health due to its physical chemical properties. Yeah, and then on the next slide, I just summed up the potentials a bit that we see in this approach, which is reducing the hazardous effluent load from wastewater treatment plants and reducing water demands in the domestic sector, while substituting mineral fertilizers, substituting manure. Maybe if a diet change is gonna happening, there's gonna be less manure from animals, so you might look into sourcing manure from humans also. And we can reduce the nutrient runoff and leachate whilst conditioning the soil with compost. Next slide. If this wasn't my last one. I think it was last. Yeah. Okay, so thank you so much for looking into it with me. I'm looking forward to your questions.
Thank you very much, Carsten, for your presentation. It was again very inspiring and very interesting to see how many changes can be done in everyday life due to these innovative technologies. And now I want to give you the floor to the public. So please post your questions, just interact with us. Okay, first question comes. How can the bioeconomy support a transition to an economy that respects planetary boundaries and promotes social and ecological well-being?
Well, I think I'm on the floor. Anita is also lifting her hand. I'll just give it a quick comment. Maybe I think bioeconomy, the largest sector within bioeconomy is agriculture. And there's a huge potential as the agriculture really impacts the planetary boundaries, not only on the green water, the blue water side, but also on the geochemical flows and climate change. So, and as I said, now we are also with the source separation able to take out novel entities from wastewater streams while gaining fertilizers. So I think it really has the largest potential to somehow push the planetary boundaries, stretches back into a safe operating space, and thereby, of course, promote social and ecological well-being, because without the ecological foundation, there's no social health, really. But I'll give the word to Anita also.
Thank you, Carsten. I think you mentioned already many topics that I would agree with, and I think overall the bioeconomy could be a main driver for this transition. For that, the actors and the stakeholders in the bioeconomy sector need to be aware of the different solutions. And secondly, the economic benefits need to be really shown and also supported. And this support of economic benefits does go hand in hand with the political support. And we have seen that earlier in one of the Slido assessments, and that is very crucial. And I think the bioeconomy sector needs support from the political sector to basically push for that transition. And pushing for that transition means that, for example, to make it very specific, farmers need to be able to use the fertilizer and use the fertilizer without having the fear that they will get punished, because it is at the moment in a legal kind of limbo status. So if these kind of cornerstones are implemented, then I think the bioeconomy sector, just by the fact of having incentives to transform, could be one of the main factors to really make this transition work. Thank you.
Thank you very much, Anita, from your answer, and also to Karsten. Let's go over the question, because I see there are a few of them. So what is the progress of permits in France and Germany? Were you referring to manufacturing permits or fertilizer registration?
So yeah, thanks for the question. David could certainly go deeper into this, but I know that as we're talking now about urine, so the product from urine, as this is already registered in Austria as a partner country, we're making use of the mutual recognition lever, basically, and this is currently undertaken in France. It has progressed quite far, and we are awaiting the certification in France during this summer. After that, in all over France, urine can be marketed, produced and marketed. It is only then when we will start the same mutual recognition process in Germany. That is our idea. We are preparing for it currently, but we want to take the learnings from France into that process, because unfortunately this mutual recognition process has to be undertaken in each partner country. So yeah, going to a new market already always requires a certain legislative process, and also resources that needs to be put into it. For the manufacturing, there's no standard or certification so far. In general, I can state that we are working on a quality standard for fertilizers, recycling fertilizers that are derived from human excreta, currently on a national level in Germany, which within the project of P2GreeN we want to bring up to the European norm level. This is all product focused.
Thank you very much for your answer, Karsten. It was very interesting to learn about this, and of course the process is going to be long, but hopefully that it starts somewhere. So we had already some countries in, and the others are coming, so hopefully that when they think that something is working, there are more countries willing to apply these new possibilities for the companies. So another question, is the urine product being already applied in gardening agriculture, for instance? I don't know if someone, like I know that David is not here, but if someone can answer.
Yeah, I guess since I'm alone, there's only Anita who's in good view also of our pilot, but it's fine for me also to take the responses. We applied it in our field trials, which started this year. It has also been applied in prior research projects, also in large scale, up to 10 hectares. So that's what's going on in Germany. And in Austria, as there's no manufacturing over there, I assume that the application rates are fairly small yet. And in Switzerland, it's marketed. The demand is really high, but the production rate is still low. So it's mainly used in smaller applications. It has been used in tennis courts in Lausanne. It's supposed to be used in the city parks, which I showed you, I think, Geneva and Lausanne, soonish. So it has not really scaled up so far, since the production rate is still fairly low, with a few pilots of Lunar Nexus plants.
Thank you very much for your answer. We'll go on with the other question. So thanks for the very interesting presentation. The question is, why Sweden has a bigger algae problem than Spain while having more than 10 times less nitrogen content in water? I don't know who is willing to answer.
Okay, I think we have to distinguish here two things. I think not Sweden has the algae problem, but all countries around the Baltic Sea, and if not the entire world, since it's somehow a common good, I would say. And then we have to distinguish between the nitrogen concentration in the Baltic Sea and the nitrogen concentration within the wastewater. So Sweden releases less nitrogen to the Baltic Sea than Germany or Spain, for example, since there's very little inhabitants in comparison. As I told you, 70 to 80% of the nitrogen contained in wastewater are coming from human urine. So if there's less people, there's less urine, and there's less nitrogen coming from wastewater directed to the seas. I think the same idea can be applied to the release of nitrogen from agriculture. There's less people, there's less agriculture, there's less end release from agriculture. But then why do we see the dead zones in the Baltic Sea more than, for example, in the Northern Sea or in the Mediterranean? That is due to the fact the Baltic is very enclaved. It's almost like a huge lake, so there's little diffusion or exchange of water. It's also, as far as I know, not as deep as the Mediterranean, for example, so the concentration of nitrogen is just higher. And also historically, there has been a lot of nitrogen release also from other states around the Baltic Sea, including Germany, I must say.
Okay, thank you very much for your answer. Let's go on. Could you share some insights on which constraints you encountered whilst dealing with different levels of public administration? Just give us some examples, if you can.
Yeah, with pleasure. So it basically starts on the municipal. How much time do I have? I will try to make it short. So on the municipal level, you already have like the problem. I would say, I mean, I understand where it comes from, and also see that it makes sense that the municipalities are actually responsible to take care of the human waste. And this is in our law. Human waste is always defined as wastewater. Basically, there's urine. The terms urine and feces don't exist really. It's considered wastewater, and the municipality is in charge of taking care of it. So once you, as a house owner or a developer of a large building complex or something, you want to take the wastewater and make use of it, you already have a legal barrier there, since you have to somehow find a way that the municipality steps back from their responsibility there. Then there's a lack of governance framework or judicial framework in the treatment side. So only already like if it is directed into the waste sector or the wastewater sector, which has unique laws. And then on the application side, you also have legal barriers to actually market the fertilizer. So there's different legal sectors where there's certain barriers. And Anita raised her hand, and as a lawyer, she can frame that better than me, I guess. So I hand over to her.
You can carry on, Carsten. I just wanted to, at the end, give a little bit of a legal framing to why it is such a constraint, no matter where we are located in Europe. So don't want to interfere you.
No, it's fine. I think, yeah, my conclusion is that there certainly is constraints, and on different levels, like different laws, but also different levels of governance from municipal to national laws in different sectors, which also makes it difficult. We have a lot of difficulty here to somehow engage the environmental and the agricultural ministry to somehow find solutions together. This is already like very challenging. Also because in Germany currently they are ruled by different parties, with having 3 parties in the government. All right, Anita, please.
Yeah, okay. Just in a nutshell, the public administration in general needs to adhere to regulations. And this is where basically the fundamental problem kicks in, because something that is not regulated or not clearly regulated is a problem in itself for public administration. And this is the case here with the approach, because human waste turned into fertilizer for agricultural application is something that not yet is in a kind of legal framework where public administration then could rely upon, could look it up, and could say, aha, this is how it works, this is what I should do, and this is why I should allow it. And as long as this is not the case, for example, for the fertilizing products regulation, where human urine and feces and converted fertilizers from that is not part of it. So for public administration, they can't adhere to anything. It's just non-existent for them. And that is basically the constraint. And no matter basically where it is it in Germany, is it in France, is it in Belgium? Because we all as EU member states are under the same legislative framework umbrella. And this is why it is so important that we tackle this challenge on an EU level. Thank you.
Thank you. Thank you very much for your answers and so for your explanation on this point that it looks quite tricky, we know, might be one of the most tricky one. So I will finalize with the last questions. How you tackle the heterogeneity of the urine chemical composition to produce always the same composition in our end product? Carsten, do you know?
Yeah, I kindly take that one as a more process engineering question where I feel comfortable. So that is a good question, I think, because really there is a high heterogeneity with urine depending on the diet, the date in the time of the day even, there's a lot of fluctuation, and that is leveled out with high volumes, basically. The VUNA systems are meant to be treating starting from 500 liters per day. So that is already quite a high volume where you mix a lot of different urine sources and achieve a certain amount of homogeneity. And then another measure is basically to have like nitrogen as the focus nutrient that you aim a certain concentration of around 4.5% to, and then the ratio of the other nutrients, mainly phosphorus and potassium, are more or less the same compared to the nitrogen from batch to batch. And on the label that I showed you before on the slide, that was actually reduced, so taking out the trace elements, which are also very beneficial for crop growth, but they will not be on the label anymore to take out the uncertainties of the fluctuations in these trace elements. I think that can answer the question, I hope.
Thank you. Thank you very much for your questions, and also thank you to all for your questions and answers. So now I will go on and I will give the floor to Laura Vivani and share the presentation again.
Thank you, Silvia, for the floor. And I will continue our webinar by focusing on the outcomes from the P2GreeN International Conference entitled Bridging Youth and the Bioeconomy. And this was the part 2 of our international conference dedicated to the World Café on Sustainable and Circular Bioeconomy. So the main goals of this exercise, the World Café, was to highlight the P2GreeN dedication to fostering a sustainable and innovative bioeconomy, and also to contribute to the collective effort to update the European bioeconomy action. So the conference has been organized in 3 parts. Can you change the slide? And the first part of this event was organized in the frame of the Bioeconomy Changemakers Festival. That was an initiative promoted by the European Union to engage young people on the future of the European bioeconomy and make them a driver of a transformative change. So this engagement of the young generations was also underlined last year at the Green Week 2023, that was dedicated to the role of the young generation, and it was outlined the need of engage them in the strategic processes and decisions. So we participated to the Bioeconomy Changemakers Festival last March, as P2GreeN has several examples of young people committed to deployment of the bioeconomy, and example, as we just see in our presentations, of young driver of transformative change. So with the second event, which was the World Café, we want to deepen the dialogue and see how P2GreeN can effectively contribute to the bioeconomy full deployment, and in particular to the update of the action plans that will then define the actions for the next 6 years. Next slide, please. So what is the EU bioeconomy strategies and these action plans? So this is an initiative that has been started already in 2012, and each 6 years is updating because is following the evolving of the situation. But by definition, the bioeconomy covers all sectors and systems that rely on biological resources. We are talking about animals, plants, microorganisms and derived biomass, including organic waste, as well as their functions and principles. But to be successful, the European bioeconomy needs to have sustainability at its heart and be circular by definition. The purpose of the European bioeconomy strategy updating is to further develop a bioeconomy that valorizes and preserves the ecosystems and the biological resources, drives the renewal of the industries and the modernization of our primary production systems. And also this would happen by involving local stakeholders. And so the final outcome will be the protection of the environment and the enhancement of the biodiversity. P2GreeN is a project, is an innovation action funded by the European Commission, and is exactly one of the actions sustained by the bioeconomy, in particular by a call that was dedicated to the circular economy. So this project is at the basis of the kind of actions that the European Commission can mobilize towards the deployment of the bioeconomy by sustaining the innovation, and also by using the evidence produced in the projects to modify some of the regulations that are becoming barriers to the full deployment of bioeconomy. So to further discuss, to come up with some outcomes, we have been discussing during our World Cafe a few days ago, traveling in Sweden with around 50 people that were really participating in the dialogue. We were discussing about 3 main aspects of the bioeconomy. Next slide. So 3 priorities that will help the full deployment of the bioeconomy. So the first priority was how to strengthen and scale up the bio-based sectors by supporting innovation and unlocking investment and markets. The second priority was looking more at the local bioeconomies and how we can develop it rapidly, local situation, local models across the whole Europe. And the third priority was to understand the ecological boundaries of the economy. And of course, for this webinar, we wanted to focus on the outcomes that were more related to the water resilience, which is the main issue in the actual Green Week. Next slide. So the main outcomes relating to the first priority that was looking at the market incentives and investment is the following one. The scale up to reclaim the water sector, to scale up the reclaimed water sector, some action needs to be strengthened. First, investing in a more digital reclaimed water management to make a better use of it and further lowering our impacts on soils. We saw the pilot in Spain. We need to replicate lots of pilots in different regions and gain evidences and standards to replicate easily these systems. And another point was lowering the price of reclaimed water for irrigation purposes to incentivize the farmers to use the reclaimed water, as in this moment, the clean water has a lower price than the reclaimed ones. Concerning the second priority, that was looking more at the local spread of the bioeconomies across the whole Europe, we have been discussing about the necessity to recognize the different scenarios in Europe. So, for example, the water scarcity in South Europe may call for more water use than in northern countries. And so we need to act consequently and planning strategies and investments, considering the localization and the territories. And that means to enhance the discussion, the dialogue at national level. And the third, let's say, consideration about the third priorities that was related with the boundaries, the ecological boundaries. To reach a water resilient Europe, it is necessary to highlight the competitive advantage of water reuse and avoiding the consumption of fresh water. So if I can say some conclusion, recycling human excreta is a crucial component of the bioeconomy, contributing to sustainable resources management and environmental protection. By integrating this approach into bioeconomy strategies, we can enhance the sustainability and the resilience of our economic systems, while also addressing key environmental challenges, such as water resilience. However, its success depends on overcoming technical, social, and regulatory challenges. We saw that. And probably it is a long pathway before reaching a full waste recovery. But with the right approach, it can become a viable alternative to conventional wastewater treatment, and so can contribute to environmental conservation and economic deployment. And if I may say, next time you go to the toilet and flush out clean water, think about P2GreeN. Thank you for your attention.
Thank you. Thank you very much, Laura, for these inspiring conclusions. It's almost time to conclude our meeting today, but before leaving, let's just open the floor to questions, if there is any question coming from the public. Okay, we have already a question. What insights from the World Café on sustainable economy are most applicable to P2GreeN, in your opinion?
Well, if I may say, there was for sure the idea that we have to stand up and to say to everyone, to all the stakeholders, as much as possible, we need a very large basis of people convinced that this is the way, even though it will take time and even though the challenges are manifold. We strengthen much more our commitment to be visible, to disseminate the concept, to collect evidence-based, to make people understanding easily that if we wanted to perceive a sustainable economy, we need to think about this solution, and this solution has to be integrated in the main strategies of the European Commission. Because actually, as Anita said, for example, concerning the fertilizers, we are not considering this material, which could have a great critical mass. So if in terms of interest from the industry is not something that we can not consider.
Thank you very much for your explanation and ideas. So now there is a question that can be actually direct to all of you. I don't know who wants to answer. How does P2GreeN engage with local communities and stakeholders to promote its bio-based solutions? I know if you have any examples done already in local communities. I don't know if Laura wants to say something, and after maybe also the others.
Yeah,
okay, Anita,
of course.
please.
Please, Anita. Many examples.
Yeah, okay. We have a couple of interactions defined in each pilot region. So I just do it broadly, and then probably, for example, Gerardo, Carsten, can give a more detailed breakdown. Activities where on a regular basis we meet with the stakeholders. We have workshops also on an interval level, so that the stakeholders that are supposed to be engaged with us also are continuously involved. And then what is also very important, a continuous dialogue at a level that is basically on operations level. So for example, in the German pilot region, we would always aim to regular inform our administrative counterpart at the municipality level, so that he or she is informed about the ongoing process, that he or she has the ability to raise questions, and that he or she has the ability also to go into the field trials and also get the data from these field trials. So this continuous relationship building is basically part of a specific activity in P2GreeN, with a dedicated work package where also professional support from our experts on stakeholder engagement are trying to guide the pilot regions with meaningful activities. And then maybe Gerardo and Carsten can give some examples how it works in practice, because I think that is always something one also understands better than what this means.
Yeah, thank you, Anita. I think it's a very good question. We have had a lot of support from some project partners in this sense to come up with the right tools and the right methods to approach local communities, because sometimes it's not easy to reach them and get them engaged. So in that sense, we have received guidance, for instance, to visit the farmers directly on their fields, instead of trying always to invite them to our events. Also take a more active role and try to communicate with them more directly where they usually have. Also to use local newspapers and even radio interviews and all these different channels at local level. And I think also for us it's quite relevant to have TROPS, which is a partner in our pilot, and it's also representing 3,000 farmers. So it has a huge potential to communicate and to replicate our solutions, but also to understand the needs and the problems that farmers might be facing. So yeah, I think there are different channels and different strategies to have an effective communication with the local communities.
Yeah, I think from my side, I can report that we had to interact with the local authorities to receive permits, to use the wastewater, permits to build the infrastructures, and permits also for field trials. So that's already a bunch of local stakeholders that we engage with, and usually find solutions together, also while consulting other communities that might already have experience with this. Then I think building up from that, from actually creating living labs, we have the huge opportunity to invite people to come and see and have a look and feel. And this is our next step to now, after that we have collected a lot of stakeholders that we want to approach, we will invite them to come and see, and also to co-create the further development of the solutions and value chains, because we need the knowledge and the ideas of them. We need the different perspective also to further mature this into a more mainstream debate, let's say. yeah, I think what is also very nice tool within P2GreeN is our cross-fertilization workshops. We had one undertaken in Malaga already, where actually representatives from local communities of our pilot regions got to learn to know each other, the different approaches and the barriers that they locally had. And I really found that very wonderful to see these different perspectives, and I think they also liked the the broader perspective and to have the opportunity to engage in this this approach from P2GreeN. Thank you.
Thank you very much for your examples and ideas on how to promote the bio-based solution at local level with stakeholders. So let's go for another question. Is P2GreeN also interested in aiming developing countries where the lack of water waste treatment may offer also an opportunity and need for those projects?
Maybe I can take this on from the coordination perspective. Yes, sure. I mean, the aim of P2GreeN obviously is to scale up, and the scale up does not only have to take part in Europe, but obviously there are challenges similar to the ones we just have outlined in our presentations all over the world. And therefore, we also aim and hope that our solutions can be transferred to other parts, especially where, on the one hand side, water scarcity is an issue, and secondly, infrastructure development of wastewater infrastructure is not well developed.
Thank you for your explanation, Anita. And I will go on for the last question of this session. Thank you all for your participation. So what are the main challenges in integrating solutions like the ones proposed by P2GreeN into regional economic and development plans? I don't know if some of you wants to answer to these questions.
Well, if I may, I feel there's still it is still difficult to really raise awareness on this topic. Also explaining it in a nutshell, giving the all-over complexity that it has, and really highlighting, stressing out that there's more environmental problems than climate change, which is like geochemical flows and water pollution and water scarcity and biodiversity and so on. It can be a bit overwhelming, I think. So the communication side and really pushing the topic into a mainstream debate and awareness is a challenge, I would say, so that policymakers actually have an incentive and have the drive to integrate it into regional economic development plans. That's from my side. Thank you.
Oh, thank you very much to all of you for following, for our participants this webinar, and from all your speakers of today. It was very inspiring. It was a very well synthesis of our journey, that it was very long in this month, and I hope that you enjoyed this webinar. It will be possible probably to see it again. We are going to put it on YouTube possibly, and thank you. Thank you very much to all of you, and I will stop here our webinar, and hopefully I hope to see you for next time. Thank you very much for all our speakers. Thank you.